Early 2016, I went out, talked to many people, and nobody believed us. And many even thought I was totally crazy to try to print a battery, solid-state battery, even the most difficult of all of them, because as you know, many people have been working on developing solid-state battery. So we felt that this approach that we're going to use here is going to help solve many of the issues that people have been grappling with in the solid-state world. And also, really the vision was, when I got to know additive manufacturing, 3D printing, I said to myself, my golly, we could do a lot with this stuff.
Hello there, Internet, and welcome to the 3D Print Authority podcast. This is a place where we come together to have a transparent and no BS conversation about the world of 3D printing and technology. My name is Adam Fosnot. I'm a mechanical engineer, and I have been fascinated by 3D printing for as long as I can remember. Let's get started. Okay, thank you so much for tuning in to listen to the 3D Print Authority podcast. My name is Adam Fosnot. I'm a mechanical engineer and president of PowerBelt 3D. Joining me today is Robert Bagheri. Did I say that correctly?
Correct, yes. Bagheri.
Awesome. He is the CEO of Saku, who is doing just some incredible work 3D printing solid state batteries for electric vehicles. I know we were just talking before we really started, but that's really only one of the areas that you're focused on. And I wanted to bring you on because I've been reading so many articles about specifically what you're doing. The most recent one was some patents that were just granted to you guys. So I'm so excited to dig into those different areas. Could you just start off by introducing yourself to the audience?
Sure. Robert Bagheri, founder and CEO of Saku. Is that
right.
enough for now?
That's perfect. What is your background?
So I am, my education and training is EE, electrical engineering background. I have spent many years in the semiconductor industry. In the last several years has been focused on additive manufacturing, 3D printing, advanced material, nanotechnology. And I've been very lucky and fortunate. I've been a number of startups, and this is my 8th startup that I'm associated with. So the previous 7, like I said, I've been very fortunate to work out with a lot of smart people. 3 of those startups when IPO and 4 got acquired.
Okay, gotcha. Being your 8th startup with what sounds like 7 pretty successful exits is certainly impressive. Were all of them in kind of semiconductors and nanotechnology, some of those areas that you mentioned?
Yeah, the first 6 were primarily semiconductor, and I do want to say I didn't start them. I was one of the workhorse, if you will, one of the workhorses there. But the ones that I did contribute into starting was the last 2 actually, and then but I was always part of the some of the executive team and some of the prior IPOs as well. The first 6 were semiconductor oriented, mainly semiconductor. The last one before we started Saku was also semiconductor packaging, but 3D printed. So this is my second 3D printing venture now.
Okay, interesting. And when you see yourself working with 3D printing more and more, has that always been an area of interest for you, or when did you first start to get familiar with 3D printing?
Well, yeah, when I first really got exposed to 3D printing was about, I want to say almost 8 years ago, 9 years ago. And a friend of mine asked me to help him rebuild a company that was a 3D printing company. But the 2008 crash made them kind of reset, and they had to go in a hibernation, if you will, for a while.
Okay.
And so then when I came in, and that was my first exposure to 3D printing, but that was a little bit, I would compare to what we have today, I'll call that very primitive.
Okay.
But it was my first exposure to 3D printing. We used that actually to build the thinnest semiconductor chip, the thinnest, which is the QFN package. So people in the semi world know that it's 0.4 millimeter.
Okay.
With our approach, we actually made it even thinner, 0.2 millimeter for mobility and things like that.
Gotcha. It's so hard for me to wrap my head around how thin that really is.
That is
And
very, very thin, and you can just really just a little bit thicker than the silicon that is inside of it.
gotcha. That's incredible. And then today you're leading Saku. You said you've been operating in stealth for a few years now. When did
Right.
you first get started kind of pursuing 3D printed batteries?
So yeah, March of 2016 is when I started to go out to talk to people and try to raise money. Of course, nobody believed us that we can print ceramic and metal together to actually print an active device, what we call an active device, anything that has power of fluidics, right? A battery, for example, or microfluidics devices like a microreactor that I showed you here. So this is, it requires multiple material, multiple process capability in the AM side of things, the additive manufacturing side of things. So early 2016, I went out, talked to many, many people, and nobody believed us. And many even thought I was totally crazy to try to print a battery, solid state battery, even the most difficult of all of them, because as you know, many, many people have been working on developing solid state battery. So we felt that this approach that we're going to use here is going to help solve many of the issues that people have been grappling with in the solid state world. And also, really the vision was, when I got to know additive manufacturing, 3D printing, I said to myself, my golly, we could do a lot with this stuff. And especially if we can bring that multiple material, multiple process and methods capability all together under one roof, you can literally build anything you can dream of. Honestly, I mean, this is like, for the most part, we're agnostic on many of the material. We could use any material and basically any device, many devices. I wouldn't say 100%, but 80% of products out there we can print. And the battery side, because we're material agnostic, we can actually work with various chemistries. With most of the chemistries that exist, we can actually use our additive manufacturing to do this. So when I came to see this, the potential of this, I said, we can really change manufacturing, and we know it. So there's a huge initiative by many companies in the AM world, the additive manufacturing world, and towards this transformation, the digital transformation of manufacturing. What we have, it unlocks opportunities, things that people just never thought of before you could do with AM 3D printing. And we also could do it very fast, so it's very economical. Most people think of 3D printing for prototyping, it's slow, expensive. Well, all of that is correct for certain type of 3D printing. But what we have developed allows us to build things at very high volume, radically lower cost, right? And more importantly, I want to say, whether it's the battery or anything else, it's green technology, it's clean. Anything we do in powder form, it can go back to powder. So you can recycle it much easier at much lower cost.
Awesome.
So that's how I came about to doing this thing. We said, you know what, we're going to go conquer the world with this.
That's
cool.
So cool. I love how you were able to get exposed to 3D printing and make that mindset jump immediately from, oh, this is cool, it's for prototyping, to there's so much potential here, not only to make things in different shapes, but also to change how we think about manufacturing as a whole.
Absolutely.
Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
Just to set some context here, what is a solid state battery and why is it better than electric battery technology that we're using today?
Well, as you may know, that today's rechargeable batteries, right? They use, of course, many of the chemistries are similar between a regular liquid electrolyte battery and a solid state battery. So the main difference, obviously, is that separator. In the traditional rechargeable battery, they use liquid, which, liquid is the best conductor. So that's why it's hard to match it with any other method. So now the people have been working for many years, try to come up with alternative to that, liquid electrolyte, because as great as liquid is from a performance conductivity side, it's also the Achilles heel. It's the problem too.
Okay.
Because liquid catches fire, it heats up, and those batteries catch fire. In the solid state realm, you're using a different type of, a separator material, electrolyte material that, various people use different types of material, but for our case, we're using ceramic. Then ceramic is very, very heat resistant, and it's very robust and rigid. It can work at very extreme temperatures. So there's a lot of advantages to building the solid state battery over the traditional liquid electrolyte battery. That's why there's a lot of investment going into it from everybody in the world.
Yeah.
All continents.
I've heard and read that the solid state battery is like the holy grail that so many people are chasing for.
But I would say no longer.
No longer.
because we really have figured out how to do it, because many of the reason it truly is a holy grail, because for those who really effectively still using the same methodology, same process to try to build solid state. It won't work for all flavors of solid. It might work for some flavors of solid state battery, but not for certainly the type we're looking at. And I know some other people are looking at also using some type of ceramic or some combination of ceramic and other material for that separator piece. And that just can't work in the current existing infrastructure. The roll-to-roll process that many people use and are familiar with. We are coming up with a completely new approach. We're using additive manufacturing, 3D printing to get around all of those problems that many people are dealing with. That has to do with handling of the material, because, for example, in the case of ceramic, it's brittle. If you got to build it very thin to get the performance. If you make it very thin, then you can't handle it. It doesn't make good contact, so your yield is bad. You can make it in a lab, but you cannot scale it.
Okay.
And so AM 3D printing is really the solution here. It can address all of the technical issues that many people have been dealing with, but it's also scalable.
Gotcha. So you mentioned ceramic manufacturing and handling being some of the issues around solid state batteries. Are there more really common hurdles that you're getting over?
Well, yeah, absolutely. Again, being able to deal with, even with ceramic itself is challenging. It's the way, one of these issues, it's the best material to get the highest performance, but it's also the most difficult to handle and deal with some of the negatives of certain ceramic material you use, because that causes, very quickly can cause shorts.
Okay.
In that. So those are some of the problems. There's issue of uniformity and kind of defectivity at the interfaces of the various layers. Those are things that it's just very hard to handle the traditional method. And the AM 3D printing solves many of those technical problems as well. One of the other major issue is the stacking of getting high energy density for the cell. You have to be able to stack those, and you can't stack those properly with if you're going to use some kind of a ceramic material or some kind of a solid material, because the old way they do the laminated or hot pressing, that won't work for this type of material. So the way to get around that, again, is this layer depositioning process that we use, all at the powder form, that allows us to basically deal with any of those issues that others have.
Yeah, you mentioned stacking layers and building battery cells. When you think about how a battery is made, or at least when I think about it, it almost makes perfect sense to 3D print it, because it's a layer by layer process. And if you can alternate between different materials, it seems almost like a perfect marriage.
Absolutely. Absolutely. So this one right here. I don't know how well you can see it.
Yeah.
This is ceramic. And actually this is five cell back to back.
Okay.
Built. And because with the printing, you can go in and just build them back to back rather than having to press them, right? You can just build up.
Yeah.
And we call it inside our own environment, it's like build it like a bookshelf, basically.
Okay.
And you can put cells on top of each other, and then you can build as high as you need to build them. But let's say in a battery pack for automotive application, for EVs, we can actually build a pack, a 27 amp hour cell, if you will, that's only 2 centimeters thick.
Okay.
So it's very 20 millimeter, right? So it's very efficient. And again, just many advantages you get with this approach.
Yeah.
Also, AM 3D printing allows you to use basically half as much material for the same energy density, for the same performance.
Okay.
Or double the range of your car.
Yeah.
Imagine if you got 8,000 those 18650 cells in your Tesla car. With our approach, you can either double that energy of the 8,000, which means it can now, instead of 300 miles, you can go 600.
Okay.
Or you can actually half the number of cells from 8,000 to 4,000 and still have the same range.
Okay.
Because we can, in that same cell, we can put double the energy density.
Yeah.
Because the way we build it.
So looking at the battery performance, you can get twice the density per,
Energy
I'm going to say energy density per like cell volume. How does it compare in terms of weight, and how does it perform in terms of charging and discharging? Because I know those are a couple important areas.
So weight, of course, will be about 40% lighter, because one of the biggest things we get rid of in this way that we build, see, this thing is ceramic, is self-packaged.
Yes.
So package is almost 1/3 of the whole, any cell. You see they do this metal casing around for protection and all of that. But we don't need a lot of that. We put another layer of ceramic around it that could hermetically seal everything.
Okay.
So that reduces the weight, reduces the amount of material we use. Every other layer inside the cell also shrinks, just because we use what we need for the performance that we're looking at. And so that's why it's lighter, because we use about half as much material for the same energy density. In terms of charge and discharge, it's a function of how thin, among other things. Of course, you can make that separator, and really the only way to make it very, very thin is through 3D printing. So with that, we'll be able to basically meet all of the charging and discharging requirements of the EV guys or the tool guys or consumer devices, you name it.
Okay. I want to get into some of the specifics of what you're 3D printing eventually, but while we're on the topic of the EV guys and the tool guys and consumer products, where do you see this technology going first in terms of those areas?
So we're right now, as I said, this is the platform is capable of dealing with multiple verticals, multiple product verticals, if you will, right? We're starting with battery as our first vertical, right?
Okay.
And then after that, we're going to go to pharmaceutical, biotech type devices like this microreactor for pathogen detection testing on other devices like in DNA sequencing. So that's our second vertical. We're also looking at other parts of electric vehicle that our platform can print various parts and pieces for. And the other one, so that's third. The fourth we are seeing is electric motors.
Okay.
Many people are approaching us, want us to build those little tiny electric motors that go into your hair dryer or your vacuum cleaner or in the car.
Okay.
Electric motors. So there are people who are trying to also build electric motors. And then, of course, is IoT. IoT is a huge market, and also many different things fall under that. But sensors, IoT sensors is the fifth vertical that we can look at. But then, you know what, from there, it's really a sky's the limit. We can go anywhere we want. It's a question of, obviously, resource and priority and focus. Our very first focus right now is battery.
Okay.
And what I just described, the 5 verticals, that's more than $1 trillion addressable market.
Oh, I'm sure.
Very high growth markets.
Yeah, when you're describing those areas, none of those areas are small by any means.
Yes, yes, indeed.
So there's a lot of room to grow there. When you look at the batteries specifically, do you imagine that you'll be producing them? Well, actually, let me back up one step. Do you imagine yourself producing the batteries as like a manufacturer for different companies, like an EV company, or do you imagine yourself building the printers and the platform and then selling those to a company and they would manufacture the batteries themselves?
Hey there, real quick. If you are enjoying this episode, could you do me a favor and subscribe wherever you might be watching or listening? It's totally free. It helps you not miss new episodes when they come out every single week. It tells the internet algorithms to help our content reach more people, and it would really make my day. I hope you think about it. Thanks.
Yeah, so absolutely. It's a good question, great question. It's a question of business model. So it's flexible. We like to call it a hybrid business model. What that is, we have what we call a PaaS, printer as a service model. It's a subscription model, right? So we work with our customers, with our JDA or teaching customers, if you will, or JV partners, and we develop, for example, the battery for their application. Be it EV or consumer or anything really. We can build it for any type of same equipment, same tooling, different type of application. But we start working with them and develop, for example, the material set that will go for what they need. And then of course we provide to, if it's a major OEM, EV OEM or any type of OEM that wants to be the OEM of their own product, then they take the printer, yes, in a subscription model, or in some cases, we could even sell, depends on who it is and what the business arrangement we can make. And then in parallel, there are people who don't want to deal with the printer. They don't want to deal with the developing material set, because the material set is really not trivial. The ink, that you build, they use, it's not trivial. So those guys would like us just to produce the product for them with our printer. So there we have a business model where we're working with our contract manufacturing. So like for the battery, we have a contract manufacturing partner. For the printers, we could also have a contract manufacturing partner. So our business model is what we like to call asset light. Very similar to semiconductor, where we say fabless model, meaning we're not going to build our big factories ourselves, but our partners will. We'll work with our partners that will do that. So as you see, that's why we call it hybrid, because then we're able to serve the various type of customers, those who want to be the OEM, and those who just want to buy the products.
Yeah, no, I think it's very cool how you have adopted that hybrid model, because I guess in my experience talking with different companies and how they want to adopt technology, especially 3D printing, a lot of times they have very strong opinions about like, I want everything internal, I want full control over everything we do. But a lot of them are just like, I just want to buy parts from somebody. I don't want to have to make space for it and infrastructure and train people and all of that. So I like how you're kind of willing to meet the customers where they are with how they want to adopt the technology.
Well, part of it also is because the reality is this is not a quick time to, from development to prototyping to mass production. There's some learning involved. And not everybody is prepared for that, or everybody is necessarily suited for that. So you gotta, depends on who it is, you gotta sort of make your engagement model flexible, so you can support those who just really don't care to worry about the hardware, the material. They just want to buy, get the product. So this helps really get best of both. I want to say many world, not just two world, because there's an opportunity for us on the monetization side, in the revenue side, where we could get revenue from from initial NRE with bringing in non-recurring engineering, helping them get ready and do the proof of concept of their spec with our IP, and then develop the material. Later, you can sell them the material if they decide to buy the, or license or subscribe to the printer. And then of course, the yearly subscription of the software, the maintenance piece of it, and then the direct sale. So you got 4 or 5 different opportunities, concurrent opportunities to generate revenue with this. This is why the opportunity is so huge just in the 5 verticals I mentioned.
Yeah, definitely. Going over to more of the 3D printing side, you've mentioned powder a couple times. So I'm imagining this is a powder-based, powder bed process that you're using. How are you actually 3D printing these batteries, like in as much detail as you're able to share? Because powder bed is common, but multi-material powder bed is anything but common.
Correct. So it is, you're absolutely right. We won't get into too much detail, but I will tell you now. So yes, the base of what we started with is a powder bed jetted method, right? Printing. So the powder bed, as you know, that's what gives it speed. That's one of the fastest way to print, right?
Yes.
People like Desktop Metal, for example, are using that as well. So that's why they're fast, right?
Yes.
They're high throughput. But then on top of that, we add these other processes and methods because you really, powder bed gives you certain geometry, certain resolution. You can build certain sizes, but you can't build everything. Like in a battery, you need to build very small geometries below 10 micron, and then you got to build above 200, 300, 400 micron. So that's why you need to bring different methods in, so to be able to address the needs of that whatever device or product you're trying to print. But in our case, the powder bed is the base, but everything else we also do a combination of powder, maybe ink if necessary, but most everything we do is in a powder form.
Okay, interesting. After the printing process, in typical powder bed, there's a vacuuming process. Sometimes there's a sintering process. How long does it take to go from processing a file to having a battery in your hand?
So I give it to you this way. Imagine this, you can build about 2,000 AA equivalent battery in one print job about 2 hours.
Okay.
It's very fast.
Yeah.
It's very fast. It's actually, if you compare it to current methods, with some of the modeling we've done, we're about 30-40% faster.
Okay.
Than the lowest cost method today. That's why this is becoming cost effective. That's why I think it's going to finally get better traction in terms of, for all of the guys in the manufacturing guys in the world that can really use this platform to build a complete product with raw material. Start with raw, within hours, go build a product. Just like this thing here, this microreactor takes about, you got to wait 12 weeks to get the silicon wafer, right?
Mm-hmm.
And another 10 days to go through this massive OPEX and CAPEX to build this thing. That's almost like 15, 16 weeks. We could do this just in a couple of hours with raw material.
Gotcha. That's a huge improvement.
It's a huge disruption. It is a huge change the way we do things. And it's huge cost reduction. And the supply chain, everything along the way also gets a streamline.
Yeah. No, I really appreciate you putting it in context of AA batteries and hours, because that's something that's really easy for me to wrap my mind around.
Yeah. Another way to give you that with perspective, one printer, our mass production version, the Saku 3000, will be capable of producing 180,000 of those 18650 batteries, cylindrical shaped batteries. And with one printer in 1 month, 90% utilization. So again, that's another way to calculate this relative to, in a high volume environment, right? And with the big difference, in those 180,000, we can put double the energy density.
Yeah.
Okay. So the cost, look, we're able to, because of the printing, we can actually build just about most every process that out there we can adopt here. Any chemistry we can bring here, and because the way we build this thing, it allows us to do it very quickly, use just enough. You mentioned something about removing. There's almost no waste.
Okay.
In our process, the way the machine is architected and built, it's got intelligence in it, so there's inline QA and all of that stuff. And you just put down whatever material you need. When it comes out, there's no post processing.
Okay.
It goes into the oven. It comes out, it's done.
Gotcha. So it does go into an oven afterwards.
Sintering, you mentioned sintering, yes, that's part of the process.
Okay, gotcha. And I don't want to pry too much. I know that there's only so much that you can share about the technology. Yes. I just think it's very cool. Yeah. So one thing that is coming to my mind is batteries always look like cylinders to me, but with 3D printing, it opens up so much more geometry freedom. Are you able to, or do you see an application for oddly shaped batteries, right angle batteries?
Many. Indeed, we have a customer. It's one of those AI glasses.
Okay.
That they want to use. They want the temple arm. On one side, the temple arm is going to be the battery. On the other side is the electronics, that these battery with power. So yes, the beauty of our approach is we can build anything, any shape, any size. We can build something as small as a battery, as small as a rice grain,
okay,
or as big as a laptop, for example, cell size for the laptop for EV or other applications. So yes, form factor is something that is a huge advantage. It's the same. See, here's the big deal about it is it's the same tooling. Same machine can be used. If you look at today's battery producers, depends on what size or shape of battery they build, they need a line for that. And then they want to run that 24/7. In our case, it's a CAD file.
Yes.
We change the same machine that builds a cylindrical shape. You can also build the pouch cell, the prismatic shape, whatever people need. You can build it for your hearable, your wearable. You can build it for your car. You can build it for your cell phone or your computer or tablet.
Definitely. Cell phones is one of those things that kind of immediately comes to mind for me, because it seems like smartphone manufacturers are always trying to go thinner, lighter, smaller, better feel in your hand, where being able to move the battery could be really impactful for them.
Absolutely. Imagine, since you said cell phone is a great example. Imagine you have the sort of the mirror image of the PCB inside the cell phone. It's battery, and the casing is battery. Now your cell phone could actually go for days instead of hours.
Yeah.
This is huge. This in itself, it could really change the game in a big way.
See, I love how you took what I was thinking and immediately took it up like 2 levels, because I was thinking, oh, you could do like a battery just like all on the outside, or you could have it like a zigzag to work around components. But you're right, a mirror image of the PCB would absolutely be able to change the form factor entirely of what the phone. All right. So cool to think about. And I'm sure as we look into other consumer devices and medical devices, batteries and their constantly cylindrical shapes probably have tremendous influence that we don't even think about on just how the devices perform.
Yeah, one of the reasons, again, there's a limitation to what you can do with cylindrical shaped battery or rectangular or whatever. And so that oftentimes dictates the design of the device, right?
Yeah.
Because you have to plan for it, right? Well, now you can just change things a little bit where you can get creative in your design. You can build it any way you want for whatever application, for whatever taste. And now I say, okay, how can I fit the battery here? Then the only way you can do it is with the 3D printing.
Yeah. Where my brain is going with this, when you think about product design, a lot of times, I hear the phrase form follows function, but I think with 3D printing, especially as it grows into some of these more areas, you can almost prioritize function and design specifically what you want. And now we have manufacturing processes that enable you to make the form to achieve the function that you want.
Absolutely. No, well said. I mean, that's exactly really one of the key advantages of this AM 3D printing. Again, because the capability to build these active devices like a battery, right? Because not every AM can do that.
Mm-hmm.
But this, just like I say, this is what I mean by it opening up a whole new areas of innovation, unlocks a lot of new applications. Today, the battery makers, like I said, they don't even go into the wearable IoT that much because of the shape, the size.
Yeah.
It needs new investment, it needs a different line. And it's a big market by itself. It's still measured in billions of dollars, but it's not, economical enough for the big guys.
Right.
The big guys are producing billions of cells per year. They go after the bigger ones, right? They go to big cells, and then of course, because you have so much more, let's say, for EV. But there's so many other markets that you can capitalize on if you could build the right shape, right size, like I said, the right form that could follow their function.
Right.
Vice versa.
Yeah.
In this case, for us, it doesn't matter. You decide which way you want to go.
Yeah. Taking one step back, when you look at kind of the path you've been on at Sakuú, has anything stood out to you as the biggest challenge you've seen so far?
Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks.
Well, outside of, as it is the case with every startup, right? Outside of funding, if you're talking about challenge and technological challenges, or just being able to get to the milestones that you need to get, of course. I mean, this is a very complex undertaking. It is not trivial, because imagine this: we're bringing really three major core competencies all together.
Yes.
Saku is the intersection of advanced material know-how.
Okay.
It's additive manufacturing know-how. It's very unique product design know-how. For example, in the battery, we came up with this very unique monolithic design of the cell, right? Which is patented, by the way. So you got to have all of these three things come together to build in an active device like a battery. And it's not trivial, and that's why many people haven't done it yet, right? And I think you will see more and more people coming into it. Indeed, you may be hearing a couple of people here and there, they're also talking about printing batteries. But the challenge has been, the biggest challenge is typically it's on the material side.
Okay.
The right material set to work in the type of application that you're going for. And we picked battery really on purpose. 5 years ago, our vision was that, as I said, we want to give our customers a solution that they can build anything they can dream of.
Okay.
And we thought the vehicle to use that, to develop that platform, was solid state battery, because that's the most difficult thing to print. Because if you can print a battery, then you can print anything. So the challenges have been a lot, and I wouldn't trivialize this. We've gone through a lot of years of developing the right material set. We have a lot of know-how, the core competency and the skills that we got in the company. They've been involved in 3D printing and material set development for decades.
Okay.
So it didn't happen overnight.
Yeah.
Yeah. So we just assembled the right people, right group of people to basically do this, and it's a very difficult task. But we're there. We're almost there. That's why we started to come out now.
Yeah, no, it's I'm sure it's a kind of an exciting milestone for you guys to come out of stealth and to start really talking about this exciting thing you've been working on for so long. Has anything along the way been easier than you expected? Like, did something just click immediately, either, I guess, on the materials development side or on the fundraising side, where it ended up being easier than maybe you anticipated?
No, I have to tell you, it's almost, I want to say, it's never really easy for any startup. Anybody that go out there, and then, the entrepreneurs out there that go in day out and try to come up with something new, because one of the biggest difficulty you face initially is the disbelief. It's the inertia. It's the skepticism. It's just like, are you crazy? Can you really do this? So, well, come back when you've done all of this, then I give you money. And then say, well, if I've done all of this, why would I need your money?
Yeah.
Actually, that is the biggest challenge, honestly, for entrepreneurs, for people that are technology drivers, because, technology in itself, of course, is challenging, but, these are problems we can solve. But sometimes if you can't solve the money problem, then you can't really do anything else.
Yeah.
Chicken and egg. People always, because especially in the solid state battery, by the way, I want to say one of the biggest challenges for us has been, because so many battery companies have come and gone for the last, I want to say 10, 15 years.
Okay.
I mean, 15 years ago, if you went out and said you want to build a battery, solid state battery, you got money very easily. There's not a lot of history there yet, and success or failure history, I mean. And now, of course, there's a lot. And so the bar has been raised quite high for us. Consider ourselves a latecomer, because, we're only 5 years old, where there are people before us have been there 10, 12, 15 years. So they had an easier time initially to get money. But now for us, we got to prove a lot more. Okay. We have to show a lot more before we can convince people to invest, which is totally understandable. I mean, many have been burned over the years.
Yeah.
And having been in a number of startups myself in my past, I do appreciate and understand the skepticism, which I think it's healthy. It's okay. It's, we have a job to do. We got to convince people that what we're offering, it's real, and it's going to produce what we're claiming.
Yeah. So when you look at that disbelief challenge and kind of the the proof and the evidence that investors are looking for. Do you find that they're looking for you to like walk in with a functioning battery and like have proof from a technology standpoint? Are they looking for more traction from a sales perspective, or is it a little bit of both?
It's a mix, right? Depends on who you talk to. There are some people, the institutionals now today, they like to see you have something ready to go to somebody, and then they'll give you a lot of money.
Okay.
Which again, it goes back to that chicken and egg argument. If I do have something ready to go to customers, well, then I'm done. I don't need the money. And then there are those strategics. They're usually more, they're really looking longer term. There is this belief, but they also like to see some level of proof of concept, the proof that technology could work, and that's reasonable, right? So you gotta have something. You can't just have go out with PowerPoint anymore. You got to show something that you've gone beyond certain level of or risk mitigation. So you've de-risked it from the science side of it, and that's totally understandable. So that's, like I said, we see a mix. The ones really that have been very helpful over the years, and in any of the startups that I've been, is those with vision. There are people who come in and look at this thing, say, you know what, this is difficult. This may still be in a few years out there. But my golly, if this thing works, I want to be the first. I want to take advantage of it. I want to get a leg up on the competition. And we've been lucky. We've had some of those people who came in with that attitude. Some friends from Japan and others who invested in us early on, where others may have not, right? So, and those are the visionaries, right? That they usually, and they always win. Because they're willing to take a chance, and they're taking the risk. But we took the biggest risk ourselves in the beginning, because after what I didn't mention in the beginning, nobody believed us about any of this. So we decided to start a company with our own money, with our seed money. We put up the first almost $1.5 million to start the company ourselves.
Gotcha.
We literally mortgaged our homes to do it. It's a typical startup kind of a.
Yeah, but I'm sure that spoke volumes to, I guess, second round investors once you were able to approach them, and it shows a level of commitment and belief that your team could actually make this happen.
Absolutely. We had a lot of our own skin in it to begin with. And to this day, we still have a lot of our own skin in it. And it really, you gotta, especially when you're dealing with something that's very, very difficult and challenging technologically speaking, you just gotta have the perseverance, the passion, the belief that you could do it. And as long as you're not going against science, right? I mean, if you're going against science, the belief isn't gonna cut it either. But as long as you're not going against science, but it's difficult. And that has been the journey for us so far. Right?
Okay, very cool. I know we're getting towards the end of our time here, so I want to wrap up with some higher level questions. We've talked a lot about how exciting 3D printing is and what you're doing, but when you look at 3D printing as a whole as an industry, can you name something that you don't like about it? Like maybe you think it's too slow, maybe you don't think every printer should be matte black, powder coated on the outside. Just really at a general level, what's something that you don't like?
Well, we see what we don't want is what I want to say some true perception about 3D printing. It is still prevailing today. That is slow, right? That it can only build inert parts and objects and things like that. I think that's changing, right? I think that because to give a real solution to customers that could really change things for them, give them a real value. It's, we got to innovate more. You got to get into from getting just printing these objects and then let the supply chain is still somewhat cumbersome that way. I think that's the part I don't like about the existing AM 3D printing. And I think what we're trying to do here, and I'm sure many people will do or follow as well, is to make this a more viable solution from a cost, throughput, time to market, cycle time of the product, all of that. I think those are being addressed, now, and I think you'll see like more of it in the future, where it will truly replace the traditional manufacturing process.
Yeah, I think that's a great answer. There's still so many people out there who just think the only thing 3D printing is good for is prototypes or like little plastic junk that you put on your desk.
Right.
But I agree with you. Yes.
Now you can build really any active device with it, right? So I really liken this to where in this juncture in the industry, 4.0 or AM 2.0, whichever way you want to look at. We are ourselves, Saku, we are to AM 3D printing and to manufacturing, digital manufacturing, than the automation was back in the 70s to the old assembly lines. See what a shift, what a transformation that was in the 70s. Well, this is yet another major transformation coming. And I think we're accelerating it because we're enabling it with things that not all AM 3D printing can do. Yes. So we're at this moment, we're very unique.
Yeah, I agree. Outside of your products and what you're trying to accomplish with additive manufacturing, what's one thing that you're really excited about in 3D printing? So this could be a trend that you're seeing, a specific technology, or something that you want to see more of.
Well, the trend that I really envision that what's going to happen is just like, you know, in the semiconductor world, if you take Moore's law, back in the days, you know, you could build very large structures, you know, big micron level till you get into the nano level, right? So over the years, as the technology matured, as the various innovations came to help on the equipment side, on the being able to deal with very, very fine geometries in the semiconductor world, I really see the same thing happening in the AM side for building active device. Like this device that I mentioned to you, this is done today with semiconductor processing, and we're able to replace that process, expensive process, with what current generation of AM 3D printing can do, our generation. I see the next maybe third, fourth, fifth generation, we can even get into much finer geometries where maybe there's our own version of Moore's law is going to come to play. And that's really exciting because that's just going to cover a whole lot more products.
It makes me so happy to hear you say that, because I was thinking about almost the exact same thing earlier today. Is I was like, there's so many people who just don't believe 3D printing will get to that manufacturing volume and speed and quality. But if you look at what has happened with transistors and computers over time, they got smaller, faster, more efficient, so quickly when you think of the history of human technology.
40 years ago, 50 years ago, nobody thought we'd be where we are today. You got millions and billions of transistor gates are on a piece of silicon that does all kinds of functionalities, right? So I see the same, honestly, trend going on here as more and more investment is brought into this space. This is truly digital manufacturing. That is the trend. That is where the world is going to go. It's just, it's not if it's going to go, right? That's how fast and what pace it goes.
Yeah. Before we say goodbye, where can people find you? Where can they learn more about Sakuú? And if there's any specific actions you'd like the audience to take, now's your chance.
Absolutely. So we're now, of course, we're headquartered in San Jose, California. We just moved to a much, much larger facility because we're about to start to build our pilot line for the battery and the printer. They can check us out really in various media outlets there, but our own website is www.sakuú.com, and they can start there. We'll be delighted to connect with them and answer any questions they may have. And, awesome. And as also one of the things I want to say, remember we talk about the skepticism and disbelief. And many people can't quite wrap their heads around multi-material, multi-process printing. If they don't believe it, we invite them to come and visit us and we can give them a demo.
Gotcha. You know, I really wish I wasn't on the opposite side of the country, because I would love to come visit sometime and really see it in person. I'll make sure to have links to your website in all of the descriptions of where this episode is shared. Robert, thank you so much again for taking the time, and I'll look forward to connecting in the future.
Thank you very much, Adam. It's a pleasure speaking with you. Very educational, certainly for me as well. Thank you.
Good, thanks.
Thank you so much for tuning into this episode of the 3D Print Authority podcast. I had such a good time talking to Robert from Saku and learning more about his vision for 3D printing and not only battery technology, but some of the other verticals that he touched on. Make sure to check out what they're doing at sakuú.com. That's SAKUU. You can also find all episodes of this podcast at 3dprintauthority.com. Make sure to subscribe wherever you might be watching or listening, and happy printing.